It's a tempting idea, really tempting. The thought that consciousness, this big, messy, wonderful, confusing thing that is you, could be boiled down to a single molecule, a chemical we could find, isolate, and point to. We could hold it in a vial and say, this is it. This is the stuff that makes the lights turn on. It feels like something we should be able to do. Science has a history of this. People used to talk about a life force, a magical spark that made living things different from rocks. They called it elan vital, and then we found DNA. We didn't find a magical spark. We found a molecule. A very complex, beautiful molecule, but a molecule nonetheless. It was the code, the blueprint. It explained how life built itself, how it passed itself on. It was a physical thing, something we could study. So why not consciousness? Maybe there's a consciousness molecule just waiting to be discovered. It's something that our brain produces. When it's there, we are aware, we feel the warmth of the sun, we hear a dog bark, we worry about tomorrow. When it's gone, the lights go out, we're in a dreamless sleep, or under anesthesia, or worse. If we could find it, the implications would be staggering. We could measure consciousness. We could potentially create it. We could treat disorders of consciousness with perfect precision. It would change everything we thought we knew about ourselves. It would be the final frontier of biology conquered. The hunt for something like this has been going on for a long time, even if people didn't call it that. Early on, we started finding molecules that clearly had a huge impact on our minds. We found neurotransmitters. These are the chemical messengers that neurons use to talk to each other. Take dopamine. It's often called the pleasure molecule, though that's a bit of an oversimplification. It's more about motivation, wanting, and reward. When you eat a good meal or achieve a goal, you get a squirt of dopamine. It tells your brain, hey, that was good. Do that again. It absolutely shapes your conscious experience. A lack of it is linked to things like Parkinson's disease with its physical tremors, but also to a lack of motivation and a kind of inner flatness. Too much of it is linked to addiction and psychosis. So, is dopamine the consciousness molecule? No. People with Parkinson's are still conscious. People on a dopamine high are definitely conscious. It's a modulator. It's like a volume knob, or a color filter for consciousness, but it's not the on-off switch. Then there's serotonin. This one is famously linked to mood. Low levels of serotonin are associated with depression and anxiety. That's why many antidepressants, the SSRIs, work by increasing the amount of available serotonin in the brain. When your serotonin levels change, your whole world can feel different. The exact same situation can feel hopeful and manageable or crushing and impossible. It changes the texture of your conscious reality. But again, is it the consciousness molecule? Of course not. You're conscious when you're depressed, sometimes painfully so. Serotonin is another modulator. It's another knob on the mixing board of your mind. We can go on and on. Acetylcholine is crucial for attention and memory. And GABA is the main off switch, calming things down. Glutamate is the main on switch, getting things excited. Your brain is swimming in a complex chemical soup, and every ingredient changes the flavor of your experience. They are all, in a sense, molecules that affect consciousness, but none of them are the consciousness molecule. They are all just parts of the machine, cogs and gears and lubricating oil. They aren't the machine's purpose. They aren't the thing the machine does. But the search gets more interesting when we look at molecules that don't just tweak our experience, but completely hijack it. And I'm talking about psychedelics. This is where the idea of a single molecule having immense power over consciousness becomes very real. Consider DMT or dimethyltryptamine. It's a simple molecule. It's found in many plants. And fascinatingly, it's produced in tiny amounts in our own bodies, though its purpose there is still a mystery. When someone takes DMT, their consciousness isn't just tweaked, it's turned inside out. The experience is famously difficult to describe. People report leaving their bodies, traveling through impossible geometric dimensions, and communicating with intelligent entities that don't seem to be part of their own mind. Their entire reality is replaced with a different one, a reality that feels, by all accounts, more real than real. And this profound life-altering shift in the nature of being is caused by a tiny, simple molecule binding to a receptor in the brain, a serotonin receptor no less. So is DMT the consciousness molecule? It's a powerful key that seems to unlock a very strange door in the mind. It shows, without a doubt, that a single chemical can fundamentally alter the nature of conscious experience. It's perhaps the strongest piece of evidence for a chemical basis of consciousness. It proves that the stuff of our brain matters immensely. Changing one small chemical component can change everything. But it still isn't the consciousness molecule. The DMT trip ends. The person returns to their normal state of consciousness. The brain was conscious before and it's conscious after. DMT is more like a powerful software program that can be run on the brain's hardware. Like, it's not the hardware itself, it's not the electricity powering the whole system. It's a temporary takeover. This is where the simple, tempting idea of a single molecule starts to break down. The more we look at the brain, the more we realize we might be asking the wrong question. Maybe consciousness isn't a thing to be found, maybe it's a process that happens. Think about a traffic jam. Is there a traffic jam car? Can you point to one car and say, that's the traffic jam? No. The traffic jam is a pattern. It's an emergent property of many cars interacting with each other in a specific way, on a specific road system. The cars are the neurons. The gasoline is the neurotransmitter. But the traffic jam is the pattern of their collective behavior. It's a higher level phenomenon. You can't understand the traffic jam by just studying one car in extreme detail. You have to study the whole system, the interactions, the flow of information. It seems increasingly likely that consciousness is like the traffic jam, not like the car. It's something the brain does, not something the brain has. It's a process, not a substance. This brings us to one of the biggest challenges for the consciousness molecule idea, the binding problem. Think about your experience right now. You are seeing these words on a screen. Maybe you hear a faint hum from your computer or a bird outside. You feel the chair you're sitting on. You have some thoughts and feelings floating around in your head. All of these things, the sight of the letters, the sound of the bird, the feeling of the chair, are processed in different parts of your brain. Your visual cortex is handling the light. Your auditory cortex is handling the sound. Your somatosensory cortex is handling the touch. These are physically separate areas doing separate jobs. Yet, you don't experience them as separate things. You experience them all at once, in one unified, seamless reality. It all belongs to you. Right here, right now. How does the brain do that? How does it bind all these separate streams of information into a single, coherent whole? A single molecule can't solve this. A molecule can be in one place at a time. It can trigger a reaction. But how can a molecule be the unification of sight, sound, and touch happening in different places? It's a problem of organization and timing, not of a magic ingredient. The answer seems to lie in the network, in the way these different brain areas are all talking to each other, synchronized in rhythmic electrical oscillations. It's a symphony played by the whole orchestra, not a note played by a single violin. The molecule might be the rosin on the bow, essential for making a sound, but it isn't the symphony itself. This leads us to a more modern way of thinking about consciousness, which has less to do with chemistry and more to do with information. One of the most interesting ideas here is called integrated information theory, or IIT. It was developed by a neuroscientist named Giulio Tononi. IIT proposes that consciousness is, quite simply, integrated information. It's a purely mathematical and structural way of looking at the problem. It doesn't start with the brain. It starts with the experience itself. It says, what are the essential properties of any conscious experience? Well, every experience is specific. It is what it is, and not a million other things. And it's integrated. It's one whole thing, as we talked about with the binding problem. So Tononi says, any system that has these properties, specificity and integration, must have some degree of consciousness. The theory then provides a way to measure this. The measure is called phi. A system with a high phi has a lot of integrated information. It's a whole that is more than the sum of its parts. Its current state contains a lot of information about its past and future states, and this information can't be broken down into the information of its individual parts. Think of a digital camera sensor. It has millions of pixels. Each pixel is either on or off. The whole sensor contains a huge amount of information, but it's not integrated. You can split the sensor in half, and you just get two separate chunks of information. The information from one half has nothing to do with the other. The camera sensor, according to IIT, has a phi of 0. It's not conscious. Now think of the human brain. It has billions of neurons, each connected to thousands of others in an incredibly complex, tangled web. You can't just cut the brain in half without destroying its function. The activity in one part is deeply and intricately dependent on the activity in all the other parts. The information is highly integrated. The brain, especially the thalamocortical system in the back, has a very high phi. According to IIT, this is why it's conscious. This theory completely shifts the goalposts. It says the key to consciousness isn't the material, it's not the carbon atoms or the dopamine molecules, it's the structure, it's the way the parts are connected and how they share information. A brain made of silicon could be conscious if it had the right structure to produce a high phi. A brain made of neurons can become unconscious if that structure is disrupted, even if all the molecules are still there. This is exactly what we see with anesthesia. Anesthetic molecules are a fascinating case study. We've been using them for over 150 years, but we're still figuring out exactly how they work. What we do know is that they don't seem to work by targeting and destroying a single consciousness molecule. If they did, we would have found it by now. Instead, different anesthetics work in different ways on different parts of the brain's machinery. Some, like propofol, boost the inhibitory neurotransmitter GABA, effectively telling all the neurons to quiet down. Others block the excitatory neurotransmitter glutamate, preventing neurons from getting excited. But the end result is the same. They turn consciousness off. And how do they do it? From an information theory perspective, they do it by destroying integration. They don't shut the whole brain down. An anesthetized brain is still very active, but they fragment it. They break down the long-range communication lines. The different parts of the brain stop talking to each other in a coherent way. The orchestra is still playing, but every musician is playing a different song at a different tempo. The symphony dissolves into noise. The brain's ability to integrate information collapses. Its phi plummets, and consciousness fades away. When the anesthetic wears off, the molecules are cleared from the system. The communication lines are restored. The parts of the brain start talking to each other again. Information starts to be integrated. Phi goes up, and consciousness returns, often with a confused "what happened?" Anesthesia is perhaps the most powerful argument against a simple consciousness molecule, and for a more complex network or information-based theory. We can turn consciousness off and on again, not by adding or removing a special substance of consciousness, but by adding a substance that disrupts the process of consciousness. There is another, more philosophical reason why the idea of a consciousness molecule is so tricky. It's what the philosopher David Chalmers called the hard problem of consciousness. The easy problems, he said, are things like figuring out how the brain processes information, how it controls behavior, how we pay attention, how we sleep and wake. These are incredibly difficult problems, but they are, in principle, solvable by neuroscience. We can map the circuits, identify the neurotransmitters, and build a mechanical model of how it all works. The hard problem is this: why does all that processing feel like anything at all? Why is there a subjective inner experience? Why does the color red look red? Why does pain hurt? Scientists can explain what happens in your brain when you see a red apple. They can trace the photons hitting your retina, the electrical signals traveling down your optic nerve, the specific pattern of firing in your visual cortex. But nothing in that physical description explains the inner, private, subjective feeling of redness itself. This feeling is what philosophers call qualia. Could a molecule be qualia? Could a specific chemical structure be the feeling of sadness, or the taste of chocolate, or the experience of the color red? It seems like a category error. A molecule has a mass, a charge, a shape. The feeling of redness doesn't have a mass or a charge. It's an experience. Like, how can a physical object be an experience? This is the gap that seems impossible to bridge. Even if we found a molecule that was always present when we were conscious and always absent when we were not, it still wouldn't solve the hard problem. We would still be left with the question, okay, but why does this molecule, when it interacts with this complex network of neurons, produce an inner world of feeling and experience? Finding that molecule will be the greatest discovery in the history of neuroscience. We'd call it the neural correlate of consciousness, but it wouldn't be consciousness itself. It would be the physical shadow of consciousness. So, if we're not looking for a single molecule, what are we looking for? The focus in neuroscience has shifted. We're no longer looking for a consciousness spot in the brain or a single magic chemical. We are looking for the mechanisms, the patterns, and the architecture that support the process of being aware. Scientists are trying to map the neural correlates of consciousness, NCC. The idea is to find the minimum set of brain activities that are required for a specific conscious experience. For example, they can put a person in a brain scanner and show them two different images, one to each eye. The person's perception will flip back and forth between the two images. They will be conscious of one, then the other. The physical stimulus doesn't change, but their conscious experience does. By looking at what changes in the brain when their experience flips, scientists can start to isolate the activity that correlates directly with the subjective feeling. So far, the evidence points not to a single spot, but to a widespread network of activity, particularly in a hot zone in the posterior parts of the cortex, involving the parietal, temporal, and occipital lobes. This is where the brain seems to put together the rich world of sight, sound, and sensation. It seems that for you to be conscious of something, this posterior hot zone needs to be lit up with complex integrated activity. We're also looking at the brain's overall architecture. We're learning about the importance of structures like the thalamus, which acts like a central relay station, helping to synchronize and coordinate activity across the entire cortex. The constant looping chatter between the thalamus and the cortex seems to be essential for maintaining our general state of being awake and aware. When this thalamocortical loop is disrupted, consciousness is often lost. This all points to the same conclusion. Consciousness isn't an ingredient, it's a recipe. It's about how all the ingredients, the neurons, the synapses, the glial cells, and yes, the soup of neurotransmitter molecules are put together and what they do in concert. You could have all the right molecules in a petri dish, you could have dopamine, serotonin, glutamate, everything. But you won't have consciousness, because you don't have the structure, you don't have the network. You don't have the billions of connections built over a lifetime of experience humming with integrated information. So can we isolate the consciousness molecule? The answer, it seems, is no. The question itself is probably flawed. It's like asking if we can isolate the wetness molecule of water. Water is wet because of the way H2O molecules interact with each other, forming weak hydrogen bonds and tumbling over one another. Wetness is an emergent property of a collection of water molecules. You can't point to one molecule and say it's the wet one. In the same way, consciousness seems to be an emergent property of a brain. It's what happens when you have billions of neurons connected in just the right way, communicating with each other through a complex dance of electrical and chemical signals. It's the ultimate network effect. This might feel like a disappointing answer. It's less clean, less simple than finding a single magic bullet. But in another way, it's far more profound. It means that consciousness isn't a simple trick. It's not something that can be easily bottled or synthesized. It's something deeply tied to structure, to complexity, to the history of a system. It suggests that what makes us conscious isn't a special substance we are given, but the incredible intricate pattern that we are. Our consciousness is the music that our brain plays. The molecules are the instruments, essential and irreplaceable. But looking for a single consciousness molecule is like listening to a breathtaking symphony and trying to find the one single note that explains the whole thing. The magic isn't in any single note, it's in the way they are all played together. And that's a far grander, more complex, and ultimately more beautiful thing to try and understand. The search isn't over, we've just realized we're looking for a symphony, not a single key.